Great. So welcome to everyone who's joining us for today's Reactor regional session, which is on leverage GitHub Actions to publish to GitHub Packages. So today's session is being delivered by Andrew Smith, who we will hear from shortly, but delighted to be welcoming back Andrew again to the Reactor for another session. Just before we get started, I want to quickly run through our code of conduct. So hopefully everyone can see this, and it's just really a reminder to everyone that this is an inclusive environment, and just to really be friendly and welcoming to everyone who's with us today. And if we do see an understanding of differences or differences of opinions, just to really be aware of that and remain welcoming to all opinions that we might see through any of the chat today. So the session will run over the next 60 minutes. Please do ask any questions you have throughout. I'll be keeping an eye on any questions, and we'll send some links into the chat as well as we go along. So without further ado, Andrew, I'll hand over to you to get us started.
All right, thanks so much for that introduction, Emma. And welcome everybody. I'm excited to be back again to show, to demonstrate using GitHub Packages today. I'm going to go ahead and share my screen. All right. And can everyone see that all right? All right, so just wanted to give a quick shout out to the wonderful fact that Reactor is a worldwide community. I'm calling in from Pennsylvania, which is why it is 8 a.m. for me. I imagine that a lot of you are coming in from other parts of the world where the time is a lot more reasonable. But yeah, I think it's just really wonderful to have a global network of learning. So today, we're going to talk about continuous delivery and how it connects to GitHub Actions. We'll go through a little bit about what is Docker and a feature that GitHub released recently called GitHub Packages. And then we'll walk through together on a learning lab that GitHub produced to practice working with GitHub Packages. And what we'll be doing is creating a Docker image and publishing it to GitHub Packages for us is to serve as a code repository for us. So those are the broad strokes of what we'll be doing today. As we're going along, I always really do appreciate any questions that you might have. So please do feel free to ask on the chat, and I will make sure to keep an eye on that and answer any questions that come up. And please feel free to ask it at any time, and I'll just find a natural pausing point to look at the chat and go through any questions. So a quick little ditty about me. I'm sure you're not here to hear about my bio, but I've been doing software engineering for a pretty long time now. I work for a company called Transparent Classroom that helps Montessori schools. A big fan of test-driven development, functional programming, and I really just love thinking about clean code. So I've been doing it for a while, and I just I never get tired of learning new things. It's one of the things I love about Reactors, is that it's just an opportunity to, you know, catch a glance at some new technology that you haven't seen before. So I think learning is a really wonderful part of the human experience, and I'm just so glad to be helping you all on your own learning journeys. So I wanted to provide a little bit of context before we jump into some of the code. There's a couple of terms that get thrown around a lot: continuous integration and continuous delivery, CI/CD. So these are relatively new concepts that were popularized. Yeah, I mean, for now we kind of take it for granted that these things exist, but they didn't always. So continuous integration is this concept of an automated process by which you take your code, you build it, whatever building means. That might be, compiling your Java code into something that can be interpreted. It could be, taking your JavaScript project and running Webpack on it and pulling all of the files into a single bundle. So whatever that build entails, do that, and then run tests. Whoops, didn't mean to drag my image around. And then run tests on your application. So that could be unit tests, integration tests, end-to-end tests, any sort of automated tests that verify that your code is working the way that it should. And ideally, this should happen automatically. So CI is, if you've heard of Travis or Jenkins, or I believe Azure has one that the name is escaping me at the moment. So sorry about that. Basically every platform is offering a CI solution. Circle CI is also a popular one. So there's lots of different ones. And with each of these platforms, you get to configure what your continuous integration looks like. So you can tell it how to build your application. You can tell it what tests to run and when, and any special reporting that you want to do. We will look a little bit at CI in the context of GitHub Actions. That is one of the most recent entrants into the field. So GitHub Actions is what we'll be leveraging today to do our continuous delivery. So we'll see kind of a preview of it, but we won't really dive into it. But fortunately, there is a really great other Microsoft learning module on continuous integration, and it does another GitHub Learning Lab. So you can check more about that. So that's CI. Continuous delivery is the next natural step after CI of taking your bundled built code and releasing it into a place where you can upload your artifacts. Excuse me. So release could be anything like publishing to NPM or to what we're going to use today, which is GitHub Packages, or uploading some artifacts into S3 so that then your app can load them somehow. Whatever that ends up looking like. And then continuous deployment is the idea of taking any of these artifacts and sort of delivering it to your servers to use for the next iteration of the next release of your project. Typically, continuous delivery and continuous deployment are bundled, or sort of merged together into a single concept, so that continuous delivery refers to both. But that is technically what the differentiation is. But most people just say well, it's continuous integration and continuous delivery. And what they mean is both release and deploy. So I'll pause there for questions and also practice pulling up my chat window. Boop, boop, there we go. So any questions so far about CI/CD? Okay. The next term that we'll be working with today is called Docker. So Docker is a technology that was created relatively recently as well, within the last 10 years, last 15 years. And the problem that they were trying to solve was the common story that you'd hear of well, the code works on my machine. I don't know why it doesn't work on yours. Code, it's running on your operating system, and your operating system has different devices, it has different drivers, it has different updates to the operating system, and all of these can come into play with running your code and may cause slight differences. The idea behind Docker is to bundle all of the dependencies, all of the libraries, anything necessary to actually run your code, put it into a box, and then you can take that box and you can run it anywhere. And you run it by using the Docker engine, which comes with Docker. So you can take your box, you can plug it into the engine, and then it just starts running your code like magic. There's also another term, Kubernetes, that is more oriented around scaling, running, and monitoring your application. So it's related to Docker, and it's sort of like the next step after you've figured out how to bundle and distribute your application. So Docker uses this concept of containers, and containers are differentiated from virtual machines. Virtual machines are what we're more commonly more commonly think about. So you have a virtual machine that's on top of a hypervisor and some infrastructure that's hosted in the cloud. Your virtual machine can have multiple services. It can have its own binaries and libraries, and then it has its own copy of the guest operating system. We contrast that with containers on the right-hand side, where each container has only one service, has their own copy of the binaries and libraries, but it doesn't have a copy of the guest operating system. Instead, it's using the Docker engine to be able to connect to the host operating system and the infrastructure around it. So that ends up meaning that you can fit more containers onto a single physical box. You can think of containers as being an application layer abstraction, whereas the virtual machine is more like a physical layer abstraction. The containers, because they don't have a copy of the operating system, they're very fast to boot up. It'd be like trying to start your Node server versus restarting your Windows or Mac laptop. So containers end up going a lot faster when they boot. They consume fewer resources, so you can fit more onto each machine. And this is all really great because it means we can scale containers up and down super, super fast in response to demand. So if a particular service needs more capacity, you can just scale up more of the containers of service A, and that'll happen instantaneously, as opposed to trying to spin up more virtual machines and you're waiting a minute. And during that whole minute, that agonizing minute when your like server is falling over and it can't keep up with demand, you're running into a lot of trouble. So that's a high-level overview of containers and virtual machines. Okay, so with that said, I'm going to go ahead and drop a link. Oh, great question. Is Docker also useful if you want to just build your app? So I like to think of Docker as being a way to share your app with other people and have it be pretty easy. So thanks for that question, Or. Let's say you have a web app and it runs with a Node server in the backend. You could just share your code with other people and say like, oh, clone my repository, install the packages through npm, and then you can just run the server. That would be great. But there might be small differences about how that cloning happens and what the running on the Node server looks like. So Docker is a way to say, this is exactly what my application is going to look like. And when you download it and you run it, it'll just run. So we'll see that at the end of this lab, that we will have a Node application that runs, and you basically build and bundle all of your code into this Docker image, and then anyone else can download that image and just run it. They can just plug it in and just start running it, and that will it'll work. So I'm differentiating the running of the application from the building of the application. So Docker doesn't exactly build your application. Docker isn't responsible for taking all of your JavaScript files, bundling them together, grabbing any assets, transpiling things, all of that work. All of that work's done by somebody else. Docker is just responsible for taking your code and knowledge about how to start your application and have it be runnable. Does that help, Or? Great. Thanks so much for that question. So I'm going to go ahead and grab a link to share. All right, so there's a link in the chat which points to, let's open it here. A learning lab with Microsoft. So you're welcome to follow along if you want to. Make sure you sign in so you get your experience points, your learning XP. And what we'll be doing is basically walking through this lab. So you're welcome to follow along. You're also welcome to go through this after the session so that you can just watch, let it all sink in. My goal is to provide some extra context around the lab. It's designed to be self-driven, and my hope is to provide a little bit of extra language and context about how it all works and to show it working. So let's briefly talk about GitHub Packages as well. GitHub Packages is a new offering from GitHub, which allows you to publish and consume your packages within your organization. So if you've ever worked with NPM or Ruby gems, or I think it's called NuGet, there's a lot of different package managers out there for different languages and platforms. GitHub is another one of those. So that it is their way of trying to provide a way to take bundles of code, make it accessible within either your organization or to make it accessible to the whole world. So we will use GitHub Packages to host our Docker image. So remember how I was talking about that little box that we put our application into, and then that's the pluggable thing, and that's called the Docker image. We're going to take that Docker image and we're going to put it up into GitHub Packages. And then someone else can access GitHub Packages, download the image, so that's the box, and then they can plug it into the engine and get their app running. And that's what we'll be demonstrating today. Docker image, GitHub Packages also makes it easy to connect to other popular tools and publish automatically to GitHub Packages at the same time. So that when you do something like, for instance, publishing to NPM, it will also then connect to GitHub Packages and publish there as well. This is pretty cool because then you can also do things like connect to GitHub Actions and be able to have other automated steps occur when you publish a new package. You could, for instance, send off a Twitter message, or you could clean up old packages, or you could add tags, or you could remove tags, or whatever you want to do. There's a lot of options available to you with GitHub Actions. And then another really big benefit is that rather than having multiple identities and authentication systems with the different package managers, everything's just stored under GitHub. So your code lives alongside the packages. Okay, so that's a pretty decent overview of GitHub Packages. There's a lot of depth in it, and you can do a lot of exploration of it. So we're just going to be scratching the surface of what GitHub Packages offers. I'll go ahead and pause here for questions if there are any. All right. So kind of gloss through here. Right. So here's another detail that I've kind of mentioned, but let's name it more specifically. There's a term that gets used a lot called container registry. This comes from the Docker registry that exists. So this is a place where you can store your Docker images. And GitHub Packages is a place where you can do that. So the GitHub Packages is an alternative to, for instance, Docker Hub. So if we open that up, boop, boop, boop. Docker Hub is sort of your equivalent of being able to store images for the community. So as we can see here, Docker Hub is where you can have an image of Node or Redis or a MongoDB instance to run. Okay. I think that's a pretty good synopsis. There's other good details to read inside of each page, but I'm going to pop along. So the next step is we're going to work on a learning lab that is hosted on GitHub. That would be this one here. And the learning labs with GitHub, if you haven't gone through one before, it installs a repository in your GitHub account and guides you through a learning process through a series of pull requests. And it has a bot that monitors the progress. So we're going to go ahead and join the free course. This will just take a minute. Okay. So there will be a few things that we do. The first is that we're going to set up a workflow file. So we're going to be working with GitHub Actions. The next one is to set up a Docker workflow. We'll then watch it go through, we'll watch the pipeline work with GitHub Actions, and then we'll check to make sure that Docker is building correctly. So there's a couple other learning labs that are worth checking out. There's the Hello GitHub Actions Learning Lab and the Continuous Integration Learning Lab. So I'll just copy these links and paste them into the chat as well. So both of them highlight both GitHub Actions and then continuous integration and are worth checking out too. And then GitHub CI. Okay, there you go. So when we work with GitHub Actions, what we're doing is defining a YAML file inside of a .github/workflows directory. So I will go to the branch, and we can see here there's this git.github folder. And inside of there's a file right now, but it's not positioned correctly. We need to change its location from being inside of .github into a .github/workflows directory. So we'll go ahead and click on the file and then edit it. Now here's a fun little trick that you can do with GitHub. If you want to, you can type in a directory name and then type /, so like a /, and that will add it as a directory path. And if you want to change your directory, you can always backspace, and it will allow you to edit the directory name. So you type / to create the directory, or backspace to start editing the directory name. And you can go back as far as you want. Okay, so that's the file name. And now we will have it in the right location. This means that GitHub will be able to run GitHub Actions when the right steps have been reached. So if any of you have not seen a YAML file before, YAML is it's sort of like JSON. It's just another way of writing key value pairs. So you have with YAML, you have a key and then some value like hello. You can also provide numbers. You can provide a nested series of key value pairs. So you could have, if you indent it, you can say subkey 1, subkey 2. You can also have a list of values, which you indent, and then you can express with dashes, 1, 2, and 3. And I believe those are the ones worth calling out. As a little side note, YAML is agnostic to indentation, so you can use 2 spaces. You could use 4 spaces, but if you want to use, but you have to be consistent. So this kind of expression wouldn't make sense. You would need to have all of them be indented by the same amount, and then YAML will be able to read it correctly. And if you're curious, YAML stands for yet another markup language. Okay, so that we have a YAML file. And right now we're telling this action to run when there's a push that affects the Dockerfile. So this means if I make any commits that are editing the Docker, see this file, then we will see this action run. So when I make this change, the actions won't run yet because I'm only editing the actual configuration file. There are so many different kinds of triggers that you can have with a GitHub action. So you can have it run when there's a label that's applied to a pull request, or when you merge to a particular branch, or you make a commit to a feature branch, or there's lots of different options. And that's part of what is so powerful about GitHub Actions. Excuse me. Once you've specified what causes the action to run, you can tell it what jobs to run for it. Each of these is a different job. So if I kind of yank out the different details, right now we have 2 different jobs. We have a build job and a test job, and each of them will have details about how they run. You can specify the platform it should run on and then the steps involved. So each of these, remember, these are arrays, so each of these are individual steps. GitHub Actions gives you access to a lot of sort of if you say uses, that means you're connecting to one of those pre-bundled functionalities. So for instance, you can say uses actions/checkout v1. This means you're using a particular feature from GitHub Actions. If we look up GitHub Actions checkout v1, I bet we could probably find it. Yep, here we go. So each of these pre-bundled sets of functionality are just GitHub repositories. So in this particular case, it's an action for checking out a repository and pulling it down locally. And then there's all these details about how it works. But the basic gist of it is like you're pulling down your repository into the GitHub Actions environment. You can give custom names, and you can tell it to run specific commands inside of a bash environment, or excuse me, inside of a shell. So for our build, we're doing 3 things. We're pulling down our code. We're running npm install and npm run build. And then finally, we're using another one to upload an artifact where we upload the Webpack artifacts along the path public. We can see a similar breakdown for test, where we have a a testing matrix. So this is a matrix of different operating systems to run this on. And then we can specify which steps. Again, we have to pull down the code. We need to set up Node so that it can run. Pull down the artifacts. And then run install and test. So this is really quite impressive that you can, with such a small amount of code, tell your tell your application, your package, to test in different environments. You could test it on Windows and Ubuntu. You can test it on different Node versions. So right now we're going to be generating 4 different test iterations. Okay. So that is an explanation of the continuous integration. That's what that looks like. So I have placed it into the corrected directory now. I'm going to go ahead and commit my changes. For right now, for the sake of expedience, I'm not going to bother with adding commit messages. The auto-generated ones will be fine. Obviously, if you were working in a real code base, you would write real commit messages. All right. So now that I've made that change, I'm going to go back to my pull request, and it should be updated. Yep, it looks like it is merged. And because it had detected that I did what it wanted me to do, and I'm going to open up the next pull request. So now we're going to be working with Docker. We're going to start to explore the continuous delivery part of this, learning lab. So as I mentioned, Docker is a engine that allows you to run containers which bundle code and dependencies together so that software runs more reliably. And it's a standard unit of software, so you can spin up them multiple times. And again, here's that comparison of a few virtual machines versus many containerized applications. So there are a few terms that are worth differentiating. We have Dockerfile, Docker image, and Docker container. Dockerfile was the only one that I haven't really said yet. So this is a text document that expresses the commands and dependencies necessary to build your Docker image. Your Docker image is the executable package that has all of the code, dependencies, libraries, yada, yada. So this is sort of like your snapshot of your application to be able to run it. It is the box that you can give to the engine. The Docker container is a running instance of a Docker image. So when you take that box, you plug it into the Docker engine, it is now a Docker container. So you can have the image produce many Docker containers to serve a higher demand. So in this particular stage, we're going to be editing our workflow so that we will use a Docker file to deploy a package to GitHub Packages. The first thing we'll do is we'll open up the ye old CI workflow file, and we're going to change it now to say CD workflow. And we can see that now that we're properly located inside of .github workflows, the GitHub UI is intelligent enough to showcase other GitHub actions that you could make use of, which is pretty neat. We can even see like that setup Node.js environment that is used here. All right. So I'm going to grab some code and then explain what we're doing. So rather than this just being a CI, we're going to call this Docker CD. Now, technically, this is a little bit of a lie because we're also running tests, and that's a little bit more CI than CD. So you could maybe call this CI CD, but I'm not too worried about that for right now. So we're going to add one more job on the same level as test. And this new job is build and push Docker image. And it has a few steps. The first one is to, again, pull our code, download the artifacts, build a container image, and do so with a set of environment variables, including a username, a password, and which registry we're working with. So this $, curly bracket are interpolated values that GitHub allows you to inject into your GitHub action configuration. GitHub is a particular object with a bunch of metadata, including who you are. There's also a magical thing called secrets, and there's one given to you called GitHub token, which is an ephemeral token which basically gives you access to your GitHub account. So basically we're saying we want to push to the Docker GitHub packages using my username and an ephemeral password. And I'm going to push it to this repository here. Okay. So with that done, I'm going to save my changes. Commit my changes, I should say. And we can see that that's finished. Move on to the next step. So we have an action, a GitHub action, but it's not running yet because we haven't made a Dockerfile and we haven't made any changes to it. So we're going to do that now. Once again, a Dockerfile contains instructions of how to set up and create a Docker image. Ours is going to be pretty simple. I'm going to go ahead and edit the Dockerfile. The Dockerfile, by the way, lives at the root of your directory. So here's the project directory. Inside of there, there's a Dockerfile. So we'll go ahead and edit it. I'll paste some contents in here. Essentially, we are copying down Nginx, which is a reverse proxy service, which will allow us to receive requests and send them off to our node server. And by the way, I should now pause and say that this is running a node server with a tic-tac-toe game. And I would imagine if we go to source, we can see index here. And index has the full set of code to display. Oh, it looks like there's not even a node server. I was wrong about that. So now that I've added a Docker file, we can see that some GitHub actions should start running. So I can pop open the details here and take a look. So for a particular action, we can see each step, and each step has multiple, or each job has multiple substeps. You can always pop each one open to see the details, the log output for each step. So this was all about building, uploading our artifacts. Now we're running tests. So here we've pulled down the code. We've set up node. We're pulling down the Webpack artifacts. And then we're running our tests. which we can see all pass. Surprise, surprise. The final job is the one that we just added, to build a Docker image and push it up into GitHub Packages. So once again, we're pulling down some code, pull down the artifact, and now we're building the image. So this is taking the information from the Dockerfile, bundling it together into an image. And then we're going to take that image and we're going to push it using Docker push to the GitHub repository, GitHub Packages. And we're done. So this final build step connects to, if I open up not the Docker file, connects to boop-a-doop. If I go back to my workflows, that's this one right here. That's the build container image right there. Okay. So now that we have built our image and uploaded it to the GitHub Packages, we should see it. If we open up our repository, it might take a minute to show up. To open the package tab. There we go. Yeah, sometimes it's a little surprising it's not showing it from this level. Which branches are left? Yeah. It's kind of surprising. Anyway, if you go to the packages page here, we can see that there is a package that has just been uploaded. So I can click on it and take a look. And here we have that command instructions for pulling down the image. So that's the box, pulling it down from GitHub Packages. And specifically, this is for the Docker packages. So to be able to pull it and run it, we need to be able to access GitHub Packages. And because we're authenticating it through our GitHub account, we need to create a personal access token, which will allow us to access through GitHub. So I'm going to go to my settings. And your personal access token is like, it's sort of like a password that is just a jumble of letters and numbers. And you can specify what parts of GitHub this particular password has access to. So this is GitHub Packages demo. And for accessing GitHub package, we just need to click this one. And this will also give us access to both the repository as well as the write and read privileges for GitHub Package Registry. We can then generate the token. And I'll copy the token. Now, once I refresh this page, this token will go away and I will never be able to see it again. And we can see here that this is now a token. We can see when it gets used. And if I want to, I can always revoke access. So I'm going to use that to log into the GitHub Packages repository, or excuse me, to the registry. So I'm going to use a command, increase the size. I'm going to say Docker login. So again, you have to install Docker first for this to run. I'm going to connect to GitHub Packages. I'm going to give my username and my token. And now I've successfully logged in. The next step is to pull the image from GitHub Packages. So I'm going to go to my package that's connected to the project, copy it, and then I'll run it in my terminal. So here I am pulling down the image, and then this is the box, and then I'll be able to plug it into my engine and be able to run the application. We're waiting for that to run or other ones. Can we add auto version changer code that can update the version after every change made to the app? Yes, definitely. There are lots of ways to achieve this. When you're building new Docker images, it's creating new SHAs for you. So that's a way to uniquely reference that. But yeah, with GitHub Actions, there are ways to apply, there are ways to like auto increment. And it's definitely worth exploring. So thank you for that question, Munshi. Seems like this got stuck, so I'm gonna just try restarting that. Sorry about that. It seems like I may have had an internet glitch. Can you all hear me again? Great, cool. So let me try doing that pull one more time. And now we can all behold my embarrassingly slow internet right now. We're having technical difficulties at the moment. While we're waiting, I'm kind of curious to go back to the root of the repository, see if that package ended up showing up. There we go. This is the joy of eventually consistent systems, is that you like make a thing and then it doesn't show up in a place and you're like, well, that's weird. Wonder why that's happening. Eventually consistent. Just have to wait. So yeah, eventually you can see the packages that are being created for your repository right here conveniently on the little sidebar. So I believe the way that this system works, let's go look at public. Yeah. Great. So essentially the way that this system works, the way that this Docker this image is working, is that the Dockerfile is telling Nginx to set up. And then we're basically going to say, hey, Nginx, whenever you receive a request, an HTTP request over a specific port, I want you to just pass it along to basically a web access. And that sort of routes into the index.html. And the index.html is where essentially our code is being hosted. come on, buddy, you're so close. Okay, let's try it one more time. Let's make sure I've got the right command. 4, 5, 3. Yeah, it might be, maybe there's something weird about the command that I copied. Try that again. There we go. Yeah, not quite sure what happened there. Somehow the command ended up changing, so just copying it again fixed it. Okay. If you ever wanted to discover bugs, you just have to do a demo, and then you'll discover all of the problems with the system. All right, so now we have successfully downloaded our image. And if I go to my Docker dashboard, and I look at my images, I can see I have one here. I could run it from here, but I'll go ahead and show the command line command to do that. So to be able to run it locally, I'm going to say Docker run, and then I provide a couple of extra incantations. I specify which port I'm passing along, some more incantations, and then I need to say which image. So to be able to figure out what image I'm working with, I can say Docker images, and that will give me a list of all of the images I have access to. So I'll reuse that command. So I give the name of the repository. And then after that long string, I give a colon and then the tag. So this is saying which specific image I'm wanting to run. I'll hit enter, and it gives me this big old hash value and then disappears. That's because I told this to run in the background. If I go back over to Docker and I go to my containers, we can see that now I have a container running. So I took that image, I plugged it into the machine, and now I have a container that's running Nginx on port 8080. And it is then piping requests along. So I can go to localhost 8080, and we can see I've loaded up my tic-tac-toe game. I can say first name is Andrew, second name is Bob, and we have our game. And I can play tic-tac-toe. Bob is not very good at this game. Ta-da! Andrew wins. Ooh, running out of power. It's fine. I like to live dangerously. We're going to be fine, I promise. All right, and that's the end of the exercise. So once you go through your learning lab, be sure to go through back on the Microsoft page, go to the knowledge check, and there's a little quiz here, as well as a couple other steps to talk about other uses of GitHub packages, which I mainly showcased earlier on in this presentation. But yeah, do the knowledge check because it's a great way to get some more experience points. You can rate the module. That is always much appreciated. And speaking of rating things, that brings us back to next steps. So the Reactor community is quite wide. There's a great YouTube channel. There are meetup groups. There's a Twitter handle to follow. There's a newsletter to follow. There's a calendar. So there's lots of great resources there. I'll keep this link up at the end. But the next thing is to, speaking of rating things, to provide feedback about this reactor. So I'll go ahead and copy some info into the chat for you. All right, so that is the survey link as well as the event code. As always, we really do appreciate your feedback. It is the way that we continue to learn and grow. So please do give us your honest feedback. We do look at it. It's not like it's just screaming into the void. We use this as a way to make sure that we're, doing a good job. All right. So I'll go ahead and pop that other slide back open, and then I will pass it back off to Emma. Thank you again, everyone, so much for your time. It's been